Okie dokie. 1, 2, 3, 4, 5, 6. Alright. Some audio syncing stuff there again. So, this is part 2 of the video from last time about some errors. Okay. I had some bugs in that first code that I should have found probably much quicker. So remember in the last video I had this. Okay. Actually, I'm gonna turn this off again. I had code that looked like this. And let's see here. Cat. Just so you can see the contents of the make file. So I'm going to run this program. Okay. Should do it. Okay. So we remember this. All the junk it printed out, and I was trying to figure out what was going on in the video. So here's the problem with this. Let me show you. Number 1, see what I'm printing? So this is a pointer to like kind of like an I don't know if I want to say array, but this is a pointer of a place in memory, and I'm printing out that place. Kind of prints out that pointer itself instead of like what's it pointing to. So something like this. Also, you know what? This is actually wrong. So what I need to do here is put this in parentheses. Put the plus plus over here. That's what nearly needs to happen. So now this is even still wrong, but we're gonna start with this. Okay. Compile. Okay. You know what? Hold on. I want that other file to be deleted too. Okay, so I fixed part of it, right? It's not perfect. Let's see what happens. It crashed. Okay. Now I see that weird data there. Since I'm printing stuff out, and who knows what I'm printing. Let's use this utility because it's cool. Look at all those nulls are printed. Okay. So. Still missing that letter C. I'm going to get back to that. So look at all these nulls you printed. Now, I thought my loop would stop when it found a null, right? That's what we thought. Now, again, kind of similar to the other problem I had, this is a pointer thing that I need to see what's at that location. So if I want this to work, it at least needs to look like this. That was missing last time. And let's see here. Okay, so there we are. So now it stopped crashing. Now, scroll up here. This is not even the whole greeting, right? Again, back to our other tool. So what happened to our letter C? Here's what I didn't notice before. See that? Right there? So this value in my code, what was happening is this entire thing is a hex value. So when this was compiled, this entire thing, so this is how many characters are here? It was PIKA0C, okay, 12 I believe, in decimal. So 1, 2, 3, 1 letter, 2 letters, 3 letters, 4 letters. This whole thing is a character 5, 6, 7. And there you have it. So it would print. Alright? So there's actually 7 characters there. So yeah. So notice it stopped on the null, right? It printed out a. Let's see what it printed out. Data 0. Let's see here. Right, so it stopped at a unsigned char. Let's see. Where did it stop? Alright, let's see what happened here. Oh, right. Data, all data 0. Side. Top. Let's see here. Well, let me check something real quick. My CPU kicked up in speed. Fan in my laptop just kicked on, so I want to check what that is. What caused that? Okay. I guess just start recording stuff. But I keep doing this thing. So let's see here. Printed out Pikachu and it stopped. Let's see, it must have hit a null after that Pikachu. Let's see here. 8. Let's see, I think I understand. Okay, so it's A, size up, malloc, memset 0. Oh, okay, memset 0. So it stopped there because I said there's 8 characters, right? And there's actually 7. So there's a null, and it put a null in the middle of a. Right, there's the 8th character's a null, and it stopped right there. Okay. So, but anyways, it didn't print out the whole thing because of that. Because this thing's actually not the right set of characters. So I'm gonna make a change here. So this loop actually doesn't work. I can't do this because there might be. The whole point of this is there be a null in the middle of it, and this won't work right. Yeah, that's why, and that's, let me show you another thing. When I put a Z here, it knows a different character. Now, see that? And it stopped there because it saw the null. Before it didn't see the null here. It just kept on marching forward because this whole thing was a value. It's not 0, it's OC. And this thing, I told it was 8 characters. So what happens is concatenated, or in that up here in this jgreeting thing, it put together 1, 2, 3, 4, 5, 6, 7, and 8. It thought it was 8 characters, so it took the null that's at the end of that data, because 8 bytes, right? Oh, that's not the right thing. Where is it? Wrong. That was the wrong thing I was showing you before. Let me see. Where is that? Where do I malloc up some? Here we are. So the size, right? So size is what I sent in. So it malloced up some stuff, right? And we did that, and stircat. Okay, jgreeting. Sterlen. My name size, right? So we copied in the null because we said it was 8 bytes long, even though it's actually 7, and it's only 7 because of this thing right here, because it's not actually 2 bytes, not null and then the letter C. It's this entire thing here. That was that's actually a pretty tricky bug. I think that's might be hard to find. It was not obvious, sort of. At least not to me right away. So that's let's see, what else can I say about that? Yeah, so how would I do this? Well, the right way to do this is to simply let's see here. That's the right way to do this. Q plus plus. Okay. Printf %c int jgreeting data. Zero print F N. Okay. Make standalone. Now ain't that odd. Okay. Let's see here. Q. That's better. So that's it. Now we're still missing that letter C. I already talked about why. Maybe I need to change this to a let's see what happens when I do this. This is the quick test here. Yeah, cool, that works. I was kind of lucky that that worked. In theory, I'd probably want this to be what's it called? Hold on, let me do a quick test here. Oh, I thought that was a C character. C letter. Okay, capital letters. So next 41. This is capital A. So let's see. 5F is what? Score. What is the letter C? Let's see. I think the capitals come before. I'm not going to spend too much time on this either. Either I'm going to guess it pretty quickly, or I'm just going to stop doing this. Let's see here. Yeah, I don't know. Let's just do this. That's what the internet's for. So, okay. Alright, I thought I typed 63. Oh, 63 hex. Alright. So, I guess I could change this to... and the H won't cause me a problem. And then I could, do that. Alright. So, that's what that problem is. And that's it. Okay. So I can escape this. I'm only lucky I can escape this because if this were, say, an N, right? I couldn't do that if the next character's an N, because as we see here, an N already that means something in the world of C code. So you can't do that. And I think it means something in Java too, and in Python. That \n is the thing. So yeah. That is what that problem was. The next thing I want to talk about is about I said, why can't I port this stuff to Python? So let's say I had a function. Okay. let's say I had a function called decrypt data, and it took right, just like we've been doing unsigned char. I don't know if this really matters right now. Well, actually, it does matter for us. This is gonna matter. So let's say an unsigned char, encrypted data, char star, game CD key, char star we key. Okay, int size, because we don't know how much data we're getting. So let's say int q less than 0, q less than 6, q plus right. Int decrypt. So q for q q equals 0, q less than 256, q encrypted, which is where encrypted data is, right, or really decrypted. So q equal game CD key, and let's say, I'm just making this number up, but let's just say the key is like that. Let's say the key is 512 bytes of something or other. Who knows? So let's see. I'll say the same thing about this too. Why not? Whatever. The key could be longer than this, could be shorter than this, who knows? Might not even be a char, maybe it's binary, maybe it's unsigned char, but for the sake of this, I just want to do this. So, and minus. Alright. So in Python, if I try to port this code, it'd be kind of tricky, right? Kind of tricky. Now, this is actually not the encryption algorithm. It's even more complex than this, probably by orders of magnitude. But can you see why this would be kind of troublesome in Python? So, one thing about GameSpy, the developer of GameSpy, they're a clever bunch, and they really like their bitwise operators, and they really like intentional overflow. They love that kind of stuff. Oh yeah, and arbitrary constants. So why don't we just throw one of these things in here? Because these guys love this too. Who knows, whatever. Let's see here. Actually, So these guys love this kind of stuff. And you may be thinking that when I come into this loop, right, q equals 0, and I say q minus 2, you may be thinking like, well, that's like a negative index. Isn't this going to crash? Keep in mind that this is an unsigned char. So when you go below 0, you wrap around and hit 255. So that's kind of how that goes. So I'm going to hit that. So I'm not going to go out of bounds on this array here. Okay. They love this kind of stuff. They really do. Let's see here. And decrypt frame equal. So something like this. Okay. This is good enough, whatever. I'll just leave it like this for a little bit. So something like that. Okay. So let's say this is their encryption algorithm. Okay. This would be kind of difficult to put in Python because Python does not have overflow, or at least not that I can tell. So if you did math like this, you're going to get warnings, by the way, using a char as an index to an array or anything like that. You'll get warnings for compiling this kind of code. But yeah, this is the kind of stuff they like to do. They love their bitwise operations, particularly exclusive OR, and they love overflowing on purpose and doing crazy math like this. That's how their stuff works. So this would be pretty hard to do in Python. I guess if you wanted to do something like this in Python, let's see. Every time you do a mathematical equation, like let's say you had I don't know, q equals 0, right? And like for example, I said I'm gonna minus 2 from q, so it's a q. Q minus 2 equals negative 2. What if I had something like this, right? So I have to do something like this, mask off the last couple of the leftmost bits off the integer. I have to get rid of some of those bits there, make them go away to do things like this. So basically my function have all these math. It's kind of complicated. I could do this, I suppose, if I really sat down and tried to really make this work, but I would think it's error prone in Python. It's easier to just use SWIG, keep it in C code, it's clean. It looks good to anybody who knows C. You understand what's happening right away instead of looking at this stuff all the time. Of course, though, if you're into encryption programming, I guess even this will be trivial to look at some point. You'll know what's happening here, that I'm basically creating a unsigned char in the world of Python by every time I do a mathematical function, just make sure I do a bitwise AND with that. I guess I can do that. Yeah, whatever. So, but yeah, this is basically why I kept it in C. There's a lot of stuff like this. Some of the challenge and response stuff, same deal. Lots of exclusive ORs and lots of bitwise operations and even some bitwise shifts, which is complicated. Now you can't do bitwise shifts in encryption and decryption like this, because that's right. Like if I did something like this, encrypted data Q equal, like let's say I did this, equal encrypted let's see, Q shifted encrypted data, no, data encrypted Q plus. I can't do stuff like this, right? Because they do this in the challenge and response stuff, though. They definitely can do this. But for an algorithm that needs to be I don't know what the term is, symmetric, or it needs to be reversible, right? When I encrypt something, I need to be able to get it back. When I do something like this, I've lost data, right? Those bits got left shifted off into oblivion, and you can't get this back, and there's no way you can recover this data. Like, as long as I'm doing stuff like this, exclusive ORs and things like that, you can always flip a couple of bits and get back to where you were originally. At least I think you can. This line right here. At least I'm sure you can return from this. You can get your data back. This line though, this line might be a little tricky to reverse. But as long as I'm pretty sure, if I understand my math correctly, as long as you're doing exclusive OR operations, you can always go backwards. This, however, when you do a left shift, you've lost however many bytes are here. You just got replaced by 0, so you can't get that back, right? So if I had I don't know, something like that, you can't get that back. You can't do this and get your data back. You've lost it, right? You can't. It went away. So, but you can do that if you're doing a challenge response algorithm. You don't really care about getting the original data back. You just want to do something, and they love that kind of stuff. So, yeah, that's it. I just wanted to cover those things, and so let's see. I've covered that C program, right? Talked about why this didn't work and why you should just use size and print out the jgreeting. Did this thing compile without an error? I feel like there should have been a warning here. Oh, that's interesting. I would have expected there to be a warning here. Let's see here. Oh, alright. I was pretty sure that this thing would complain about, see the unsigned, well, I guess the unsigned char is kind of like an int anyway, right? In the world of C, for the most part. Kind of, sort of. Alright, so, that's it. I just wanted to show you guys that was the problem with the code last time, and that's why I had to do this again. And that's it. I know if I have anything else to talk about. You know, this is a little bit of rambling here, but back in the day when I first learned C programming, you couldn't declare a variable and assign it a value at the same time like this. It had to be on different lines. I've also seen programs do things like this. Let's see, so I have that int q up there, right? I've seen programs do stuff like this as well. There was a time, at least in Windows 95, Borland, what is it called? Borland C++, Turbo. You were not allowed to use variables like this to create an array. It had to be a constant. So I noticed that those kind of things have changed. It's kind of interesting. Back in the day. Alright, I think I'm done. I'm just going to just stop this video, but you've seen kind of a little bit. I hope that solves some, clears up some things from my last video, so everybody understands it. And that's it. Until next time.